Hello and welcome to Top of the World. If it's your first time, I'm Simon. Rarely do I admit to a mistake. Rarely do I make a mistake that anybody sees. So, it's not the kind of video I'd normally make, certainly won't plan on making one, but the frustration and the lack of information and the catastrophic mistake that I've made and the time I've wasted making it warrants making the video. So, I've got a little plumbing job to do, and in order to do a small plumbing job, I have to drain 1/4 of the entire system in the winter, and we live in the Arctic. So, I'm going to tell you how it goes. Due to the lack of money, resources, I'm very good at making up things I need out of what I've got lying around, what I can scavenge, what I can trade, swap or blag. In addition to that, I have quite vast amounts of stuff that I collect anyway. So a plumbing job should be relatively easy. But I'm having a quiet rant with myself and I needed coffee. So I wanted to be clear before we start, I'm not a heating engineer. I'm not an expert in pumps. And I had a niggle in the back of my mind, right? For you guys that dabble and tinker and, you know, make things out of stuff, we've all done it. Like, the learning curve is vertical, and mistakes, you only make those once. Well, at least in a given subject, you should only make them once. And this is about one I made, even though in the back of my mind, and for you guys that know, you've got something in the back of your mind telling you this is not going to work, and you even know the reasons why, but you can't actually define or obtain the information accurately at the time of the build to give you the answer. So you carry on regardless. I've done that. Yep. I got about 12, 14 hours into this project, failed miserably. And now I'm going to show you why. So I've made these up. Right. And these have got to be inserted into the pipe so I can take a spare off of for an additional radiator. And this is what I've got. In the dingy dark corner, not yet or not previously exposed, this is where the previous owner in 1980 capped off the heating system. These two spurs go to a bathroom. But these two are main flow and return and should connect to those. And as you can see, they don't. But what these are going to allow me to do is these pipes will slide up and down. These will connect in here like that, so, and allow me to take a spare off. Okay? But what I have to do is the two radiators are connected to these, which is one on this, the floor above us, and the one on the floor above that have to be drained down. And they have to be drained down from the cellar. And here we are in the cellar. So up here, previously the pipes were cut there and here. And I've put this in with this valve to reconnect the quarter that we saw upstairs. In order to drain it down, I shut down that tap and that tap. And I crack that out and that out, and I can empty all the water out of these pipes which drain that quarter. Then I can do the alterations to the plumbing work that I want and refill that quarter. The only way of refilling that quarter is to take all the fluid right to the very top of the building, up 100 stairs and a ladder, and pour it in through a very small hole. No, because I have an additional issue that I've been wanting to resolve, and that is how to get the chemicals into the heating system. Is it dark in here? It's dark everywhere. Right, so here we are in a rather smoky furnace room because I've just lit the furnace. So, in order to fill the system, ouch, there is this spur coming off with this tap. And originally, and for all the years I've owned the business, and who knows how many years before, that was connected to this white flexible hose over here, which at one point had a pump at one end and a hose. And in order to put in glycol, you would put the end in there, switch the pump on, open that valve, and it would start to fill the system. You can also fill the system with fresh water from there. But it's an open system. I'm not even going to go into all these systems. It's an open system with a big tank at the top and an overflow that comes back down into the cellar, which is that pipe there. And it goes to drain. Well, I've cut that pipe now and I've put on this flexi pipe so that I can put that in there. And I've added this tank and I had hard copper plumbed it to the system. Now the idea is I can put all my chemicals in here and or any water that I drain out the system I can put back into here and pump it. It's simple. It's not a complicated system. It's simple. All I needed was a pump. I haven't really been to town and I don't have the money to buy the pump that I should put in there. So I thought I would use a pump or some pumps I've got lying around. I don't have a diaphragm pump, but I don't have a piston pump. What I do have is a lot of central heat and circulation pumps, like this. That's a circulation central heating pump for a short circuit. That's a large central heat and circulation pump. What I have, that I've managed to scavenge, is a number of these small Grundfos circulation pumps. So my initial idea, once I realised I couldn't get a pump, was to connect that to the bottom of this tank, plumb it all the way around. However, before I done that, I tried, let me just see if the furnace needs wood. Well, that's not looking good. Give it some more air. That's not looking good at all. Give it a lot more air. I tried looking up, using the internet for as much information as I could, to see if I could find anybody or any information on whether a circulation pump will push against pressure. And I couldn't find anything. Find lots of other questions. Can you use a circulation pump for circulating the water in your pond? These kind of questions. And other questions that were particularly unrelated. So, this is a standard circulation pump. And I want to show you what I know. So, what's inside a circulation pump? Well, this is one I've renovated. That's the housing. Water enters through here and exits through there. Enters through there, exits through there. And this seals here against this, but it doesn't seal very well. It's not a tight seal. This spins, pushes water out through the fins. It does that. The problem with this, as I've always known, is when the pump's switched off, right, the water can still flow because it doesn't have a diaphragm or anything to stop it from flowing. It's open. It's an open pump. Its design is just to circulate. So we've got this open now. What makes these pumps so reliable, that's it working. If you put the housing back on, even while it's working, right, I can feel air being pushed out from there and sucked in there. Right, it's pumping air. It's pushing. It's pushing. And there it is running. I'll just take a quick moment just to show you why they're uber reliable. He says, now he's already had this open. The reason these are uber reliable is because they don't have a motor. See that? It's magnet driven. And the beauty of having a magnet driven circulation pump is if they run out of water or don't have any water or get left running and there's a blockage, they won't burn out. They don't have a motor in a traditional wound motor. They work on magnets. So I can stop this. Whilst it's plugged in, I can even pull it out whilst it's plugged in. There you go. And then if it sits back in its housing, while it's still running, depending which way you put it, it's pushing and sucking. That is how a circulation pump works. Now, can it push against pressure? Which is the whole point of this video. No, it can't. The circulation pump has to have equal pressure of both sides. Doesn't matter that it's at the bottom of the system and there's pressure above it. Doesn't even matter if the pump's at the top and there's pressure below it. As long as there's equal pressure on either side, it will pump. If you're trying to pump against pressure, because this is open, even when it's running, the water will just push back through it. So my idea and all the work I went to of connecting it up to the tank at the bottom and then opening the pressure system and hoping I could push a tank of water up into the central heating doesn't work. All I did was fill that big tank full of water from the heating system, which has now left me less in the system than I had. I kind of knew this was a big potential, but I couldn't find out any information. And then yesterday somebody popped in very briefly who has a part clue about many things, but he dabbles as well. And this video is really about people that dabble, and if they have a question when they get to any kind of circulation. Can you use a circulation pump to pump? No, you can only use a circulation pump to circulate water. So if you want to circulate water in a pond, great. But the pipes and the pump have to be below the surface of the water. And that's the point. These pumps have to work in a system with equal pressure, both sides. There's many experts out there that can give you all the reasons. Not an expert. I dabble. I make stuff out of what I find. And that project hasn't worked. I need a piston pump. I need a diaphragm pump. I need something that will push under pressure once the pump is primed, and a circulation pump will not do that. Now, irony, I met a man once, he was an accountant. Well, he was my accountant. And he was the greyest person in the whole world. Didn't get my jokes, didn't share a sense of humour, didn't share anything in common. And I asked him once, what makes him laugh? Irony, he said. I didn't get it at the time. This is midway between my shop floor and the cellar. And I've put certain things in certain places because I've got nowhere else to put them. I've walked past that hundreds of times since it's been there for a month. That's my Graco 9000 paint spraying pump. That's what I use to spray houses. Will that pump water and chemicals and fluids into my central heating and exceedingly high pressure? Oh yeah. Yes, it will. Could I have used that instead of that whole tank and all that scenario and just put a bucket underneath and connected up the hose to the central heating system and just pumped forever until something blew up? Yeah. Did I think about that? No. Did I think about it at all in the several hundred times I've walked past it? No. Anyway, I don't really want to use that because it's not a permanent solution. I can use that to get me out of trouble. Now, this is interesting. This is another one of my skip pulls that's been lying outside. What I noticed, and you can see from in here, is the housing is smashed to pieces. It's been left full of water. You can't leave anything full of water here. So the pump is no good. So I'm going to dismantle this for the fittings. And the motor, I suspect, even though the motor's been butchered at by somebody, the motor will be good. There's an air tank in here. I suspect that's no good. That's how you pressurise the air tank. So there's a bag in here that expands and contracts, and you can use that to pressurise the water and the pump in a system. It's good for drawing from wells. That's what they're used for here. is you can draw from wells. But I can't use this. It's the right kind of pump to push under pressure or to pull. It will push and pull from pressure, providing it's primed. But it's no good for my application. So I'm not sure how helpful that is. Can you use a old central heating circulation pump for pushing and pulling? No. Only for circulating. And I was sure about that. But you're never actually sure until you put it together. An easy test would have been to fix something to either side of this and hold the pump and drop one end in the bottom of the water and see if it sucks water or pushed water uphill. And of course it won't, because, and I'm sure I've explained this, I'll explain it in the easiest way I possibly can. This is your outlet, these fins here, and this is your inlet, and there's nothing to stop water passing through that, and the spinning motion by itself doesn't create pressure, or it does but limited pressure. So you cannot use a circulation pump of any sort to push water uphill. You can use it for ponds and other projects where you need to circulate water, providing you have equal pressure on both sides and the pump and the pipe work is underneath the level of the final level of water. So if you've got an open central heating system, it's got to be below the level of the water in the tank, the header tank at the very top. If you've got a closed central heating system working off a pressure tank, you can use it anywhere. And I'm not an expert. There's lots of people tell you where you can use it and where you can't use it. So it's just a quick one to explain. To help anybody that's stuck. You can use circulation pumps for a lot of things, but not to pump water uphill or to draw water from downhill, just for circulating. Anyway, that's my rant of the day. So all this mess and everything that I've been doing, well, I've got to have coffee now. I was having coffee because I've got to start again, and that probably means I have to find a pump to do what I need to do, and that means that I can't drain the system and connect up the additional radiators. And those that don't know, well, you know, winter started. I shouldn't be doing this, but I do crazy things. So we're quite fortunate. Our temperatures at the moment are under -10, so it's not so bad. But once they get to -10 and above, shutting down the heating system for too long, dodgy. Be all right if it was full of glycol like it should be. Glycol levels are a bit low. In order to put the glycol that I've got into the system, I need a pump. So that's concluding that little episode. Just any of you thinking of doing a project like that with a central heating pump, no, stop. Go and get a different kind of pump, because that doesn't work. So anyway, thanks for joining me. If you like the video, give it a thumbs up. If you're not subscribed, consider it. Helps me out, helps the channel grow. Have a great day.